Elements and the periodic table. In this video, we will focus on the 118 elements found on the periodic table. This will be useful in our study of atoms, molecules, and compounds. What is an element? The empirical definition defines an element as a pure substance that cannot be broken down into simpler substances by chemical means. The theoretical definition is given as a substance composed entirely of only one kind of atom. Dmitri Mendeleev was the first who published a periodic law. This periodic law stated that elements can be arranged by increasing atomic mass and show a periodic occurrence of properties at regular intervals. This is provided in our textbook. As this table developed, trends became evident. There became a gradual and consistent change in properties within what was called rows or periods and columns called groups. In 1911, a Dutch physicist, A. van den Broek, from 1856 to 1917, suggested a rearrangement of the periodic table according to the atomic number. This led to a revision of the periodic law. Here is the revised modern periodic table. This table shows every element in order of their atomic number. This periodic table was further refined into what the periodic table looks like today. So here's the modern periodic table. Groups are the elements with similar chemical properties in a vertical column in the main part of the table. Period, elements are arranged in horizontal rows whose properties change from left side, the metals, to the right side. The staircase line, a zigzag line, separates metals to the left from nonmetals to the right. You'll notice at the bottom that rows 6 and 7 show an arrow, and that would really be inserted into the periodic table, but for purposes of properties, they're shown at the bottom. The colors shown on the periodic table, the blue represents liquids, the orangey reds indicate gas, and the gray indicates solid. The majority of known elements are metals. All metals except mercury are solids at SATP, standard ambient temperature and pressure, which is defined as exactly 25 degrees Celsius and 100 kilopascals. Chemists can use the groups to explain common characteristics. By observing these common characteristics and noticing the location of the same group, different groups represent different types of chemicals. Let's take a closer look. First, we're going to have the alkali metals. They're shown here in green. Alkali metals are found in group 1, as I said, shown in green. Here are the properties. They are soft, silver-colored elements, solid at SATP, exhibit metallic properties, reacts very violently with water to form basic solutions and give off or liberate hydrogen gas. Reacts with halogens, remember that, to form compounds similar to sodium chloride, NaCl. Stored under oil or in a vacuum to prevent reaction with air. Next, we have the alkaline earth metals, group 2. Alkaline earth metals are found in group 2 and they're shown in blue. Here are their properties. They're light, very reactive metals, solid at SATP, exhibit metallic properties. They form oxide coatings when exposed to air, react with oxygen to form oxides with the general chemical formula MO. All except beryllium will react with hydrogen to form hydrides with the general formula XH2. Reacts with water to liberate hydrogen. Now let's look at noble gases. Noble gases are found in group 18 of the periodic table. They're gases at SATP and have low melting and boiling points, extremely on-reactive because of their filled outer shell, of particular interest to chemists because of their chemical properties. Krypton, xenon, and radon reluctantly form compounds with fluorine. Radon is radioactive. Now, let's look at halogens. Halogens are found in group 17. An element in group 17 of the periodic table. Their properties are that they may be solid, liquid, or gas at SATP. They exhibit non-metallic properties. They're not lustrous. They're non-conductors of electricity. They are extremely reactive with fluorine being the most reactive. They react readily with hydrogen and metals. Now, continuing on, let's take a closer look at what we call the representative elements. These are elements that include both metals and nonmetals from group 1, 2, 13 through 17. What are the properties? They could be solid, liquid, or gas at SATP. They're called representative because they most closely follow the periodic laws. They may form many colorful compounds. Okay, now we have the transition metals. Here's our periodic table. Transition metals are found between group 3, also shown as 1IIIB in Roman numerals, and group 12, shown as IIB in Roman numerals. Properties. They exhibit a wide range of chemical and physical properties. They're characteristically strong, hard metals with high melting points. They're good conductors of electricity. They have variable reactivity. They form ions with variable charges. They may react with oxygen to form oxides. Some will react with solutions of strong acids to form hydrogen gas. Lanthanides are considered rare earth metals, and they are the elements with atomic numbers 57 to 70. We're not going to take a closer look at them right now, so we're going to move on to the next. And now we have actinides and transuranic elements. And they're found at the very bottom of the periodic table. Actinides are the elements with atomic numbers 89 to 102. Transuranic elements are synthetic and not occurring naturally. They've been assigned atomic numbers 93 or greater. So here's the periodic table summarized. In the next video, you will look at the trends that occur within the periodic table.